Okay, so this is the first video online of how to do stuff in maths by Mr. Williamson. Welcome to the adventure. Um, I'm just going to start off by saying the stuff that we're doing and focusing on today is the things that I want you to doing this week, and that's from this chapter right here, which is Graphs 7. Now it gets pretty heavy pretty quickly, so I'm just going to take a step back and just go through a few things first. Right. So first of all, I'm just going to draw the graph of y equals. Stick with that. Y equals x squared. Oh, I love my iPad. And what does that look like? Well, it looks something like this. We've got here's the x-axis and here's the y-axis. Move that up a bit. And y equals x squared looks something like this. Okay, not perfect, but you understand. And from there, that's y equals x squared. We can see that where y equals 0, yeah, x equals 0, because that says if y equals x squared, then we say y equals 0, so 0 equals x squared, and we square root both sides, and obviously the square root of 0 is x, and the square root of 0 is 0, so 0 equals x, which is where we get that point right there on the x-axis. Now, if we then look at what about where x squared equal, what about where x squared equals 1, right? Well, here is where y equals 1. And hopefully you guys can all remember roughly that y equals 1 is a line which just goes along the y-axis like that. And it goes through the point 1. Yep. So anywhere on this line that I've just drawn, this point, this point, this point, doesn't matter what the x coordinate is. That's something like, I don't know, 1.5, 1. The y-axis, the y coordinate is always going to be 1. All right, so what's negative 2, 1? I'm just making these numbers up just to prove a point, and etc., etc. So anywhere on that point is 1. Now, where x squared equals 1, obviously we can, if we want, we can solve this algebraically. Let's just do that real quickly because it's nice and straightforward. If I've got x squared equals 1, then I take the square root of both sides, and I get x equals the square root of 1. Now, the square root of 1 can be either 1 or negative 1, so that's that or that, and the square root of 1 is obviously 1, so x equals plus or minus 1, which makes sense because 1 squared equals 1, which is what we wanted from the first equation, and negative 1 squared also equals 1. A negative times a negative is positive. So those two work. Now, what's that got to do with using this graph? Well, you can see that this line, the straight line, this one here of y equals 1. Remember, the line is just a collection of all of the solutions to the equation y equals 1. So x equals 1.5, y equals 1, x equals 2, y equals 1, x equals negative 2, y equals 1, x equals negative 2.5, y equals 1. They're all solutions to our equation. But there's only 2 points. Let's mark these with green because the 2 points where they are equal to each other, where x squared equals 1 is at this point right here. Yeah. So if we want to find out what x is, we can then just say, well, at that point there, we look at the coordinates. So we can just drop a line down to there and we can find out that x, so it should be negative 1 there, and that one should be 1 there. So what essentially we've done is we've used the graph y equals x squared to solve the equation x squared equals 1. Now, this also has another really big use. Now let's combine the two. Combine the two things. I'll show you what I mean. So if I said, what about y equals x squared minus 1? Okay, and I want to solve the equation. Oops, where's read undo? Undo there. And I just want to solve the equation 0 equals x squared minus 1. Or usually in an exam, it will say x squared minus 1 equals 0. Now, again, if we want, we can do this algebraically. And we can just go, well, we can add 1 to both sides. Yeah, that's no problem. And then we can do x squared equals 1. And we're at the same point again. We get x equals plus or minus 1. But what we're going to try and do, though, is say, well, we're going to use the graph of y equals x squared to solve this equation. And what we did before was exactly that. We used the graph of y equals x squared to solve the equation of 0 equals x squared minus 1. So what we do is we use the graph that we know, which is x squared, and then we put everything else on the other side of the equal sign. So for example, in this one here, we've got, I'll write it out again, 0 equals x squared minus 1, but then we add 1 to both sides, and we get x squared equals 1. Now, we use the graph y equals 1 and y equals x squared, plot those two, which is what we did before, and we get our answers that I did in green right there and there. So this is the simplest example of what you could possibly get, really. But let's look at another one, which is, I don't know, maybe slightly more tricky. Okay, so let's look at another equation. Let's look at x squared minus x minus 2 equals 0. Okay, and this is the question that you get in an exam, for example. Now there are a couple of ways of doing this. One, we could just factorize, which you guys should be able to do, or you could use the quadratic formula, which you could use you could even use your calculator. I've got my calculator right here. I think I'm going to do that first. No, I'm not going to use my calculator. I know how to do this. So I can see that factorizes to x minus 2 times x plus 1 equals 0. Just remember using FOIL, x times x is x squared, outer, inner, last, and remember the sum has to be that minus 1x there, and the product has to be negative 2. Minus 2 times positive 1 is, so that works. Let's get rid of those two lines down there. Okay, so where are we now? That means that x equals 2 and x equals negative 1, because if x equals 2, that bit there equals 0, and 0 times anything is 0. And if x equals negative 1, that bit there is 0, so that 0 times anything else is also equal to 0. So I've already got my solutions here, but let's solve it using the graph of y equals x squared. Okay, so how do we do this then? Well, let's draw some more, let's draw another thing, a new set of axes right here. Turn off the ruler, see you later. Right, and we're going to draw it again. We're going to draw y equals x squared. It looks something like this. The left-hand side of my graphs always don't look as good, but you get the picture. Now, that's my y equals x squared still, the one that I'm happy with, nice and easy, nice and straightforward parabola. And I'm just going to go down here, and I'm going to write x squared minus x minus 2 equals 0. Now, like I said before, we need x squared to be on one side, but we need to get rid of all this stuff and put it on the other side of the equal sign. So I'm going to add x to get rid of the x, and I'm going to add 2 to get rid of the 2. And of course, I have to add x and add 2 to the other side of the equation as well. So that gives me x squared equals x plus 2. Now, I don't know what the graph of x squared minus x minus 2 equals y. I don't know what that looks like, but I know what the graph of x squared looks like, and I know what the graph of x plus 2 looks like as well. And in fact, I'm just going to draw the graph of y equals x plus 2. Let me think here. It's going to, I might have drawn it a bit too small. It's going to look something like that, but my graph isn't going to be very accurate. So I tell you what, just because I can, I'm just going to go quickly to Desmos here. Oh, look at that. It's almost as if I had this planned. So I've got y equals x squared right there. And that's the one that I was trying to draw pitifully. I'm sorry about my drawing. And I'm also going to plot on y equals x plus 2. Okay. Now, you can see here that, actually, can I be really cheeky? I bet I can. If I take a screen grab of that and then go to there, and I can do a markup on here, perfect. Right, so if I look here now, I can see that those 2 points are where the graphs overlap. So that's where you've got the graph of y equals x squared and the graph of y equals x plus 2 are equal. So we've found our 2 solutions. Now, how do we find out what x is? Because that's the thing that we originally wanted. Well, we just drop those lines straight down to here, and we get x equals 2. Oh, that was one of the original solutions. And here we also get x equals -1. Okay, so that works, doesn't it? Yeah, so let's just crop that, see if we can put that into our notes. Save to files. Oh, just save it anywhere, I don't care. On my iPad. Save it right there, I don't care. And so going back to my notes, so we worked out from that thing there, you'll be doing it a lot more accurately and carefully, of course. You get -1 and x equals 2. Now, we already worked that out algebraically beforehand, right over here. So working it out algebraically, that works and it gives you your answers, but it doesn't give your answer using a graph. And sometimes the examiners, they like very much to say, using a graph, solve this following equation. And if you do it algebraically, you'll either get 1 or no points. You probably even get, you'll get no points because they always say if you get the right answer but use the wrong method, then you get 0 points. So you have to be able to draw these graphs. Okay, now let's look at one more. Okay, this is more along the lines of the well, actually, it's the one from the book. So let's go to the book. I'm on page 216 of the book, and right here, this should start by looking a little bit more familiar now. So what we are doing is, yeah, red. We're solving that equation. And the question in an exam will be, solve the equation x squared minus x minus 3 equals 0, giving it answers to 1 decimal place. Make sure you're giving it to 1 decimal place, otherwise it will be wrong. So again, rearrange the equation so that x is on one side. So from here, yeah, we're going to add x plus 3 to both sides of the equation. So I get x squared equals x plus 3. Draw the line y equals x plus 3. If you're not sure, remember you've got y equals mx plus c, where m is your gradient. Here the gradient would be 1, and your c is your y intercept. So we've got the gradient of y-intercept. So for this one right here, hang on, draw the line y equals x plus 3. My gradient is going to be the coefficient of x, which here is 1, and here the y-intercept is going to be 3. So the gradient goes, this is not a very good example in the actual book, because the gradient of this line actually is 1, although it doesn't look quite like 1. It looks kind of like a half, but you can see as it goes across by 1, it goes across by 1, it goes up by 1 as well. So sorry about that from the book, but hey, never mind. So we've got y equals x plus 3, and we've got y equals x squared. We've drawn those two things, and where those two lines meet is your solution to your equation, where y equals x plus 3 and y equals x squared are the same. Same x, same y. And again, that makes sense because those two solutions, those 2 points where the lines meet, they have a coordinate, call it x1, y1, and x2, y2. Yeah, they've got coordinates, and the x and y coordinate is the solution. So because we're doing this graphically, it's not going to be super accurate, but it's going to be accurate enough. I think you can see from here, it's going to be -1, that's -1.5, -1.5. So I would call that -1.25 perhaps, and maybe this would be 2.2, I don't know, 2.2. I would say it's more like 2.25. I'll say it's more like 2.2. I think the book's wrong. So this, but to one decimal place, this would be -1.3, because if it's bit 5, it rounds up. And this here, because I've said it's 2.2, my answer would be 2.2, not 2.3. Stupid book. Okay, it's not a stupid book. I'm sorry, book. But you can see that the accuracy isn't super good, but you get within like spitting distance of the answer. Now on your actual exam, they will say they'll give you a range, so it'll be something like anything between 2 and 2.5, or maybe 2.1 and 2.4. That would be fine. Now what I am going to do though is I'm just going to go on my calculator. I'm going to press menu. I'm on the 991EX Class Whiz, the one that you all should have, and I'm going to go to equation function. We've used this before. Polynomial degree 2. I'm pressing the buttons on my calculator as I go, and I've got for my A, I'm going to put 1. For my B, I'm going to put -1, and for my C, I'm going to put -3. And I click equals again, and it gives me 1 plus root 13 over 2. Ugh. And the answer here is 2.3. Oh, maybe I was wrong. Never mind. But the answer here is 2.302775,638. And the other one is -1.302775,638. So our answers are pretty good. They're not super accurate, but they are accurate enough to answer this question. So that's one example from the book. I'll just go through this other example, which is the next one on. But I'm going to use exactly the same thing just because I can, because this x squared, the green line here, is just such an easy thing to start with. Because I don't know what the graph of y equals 2x squared plus x minus 8 is. I'll have a go though, actually. I didn't prepare this one. 2x squared plus x minus 8. Turn those off. And I'm going to go 2x squared. What was it? 2x squared plus x minus 8 plus x minus 8. And okay, you can draw the things, and you can see that the 2 points are going to be those two. but I don't like to have to draw something like that. It sucks. So what I need to do is be able to uh, use a different way of solving it, because that's not a very nice graph to have to solve. So again, we go back to our notes here, and we rearrange this guy right here to something else. Now, what they've done here is they've actually divided by 2 for everything. So we've got x over 2 minus 4 equals 0. X over 2 is just because we've divided by 2, because what we need to get is that x squared on its own. So then I'm going to go minus x over 2 plus 4 to both sides. Oops. Plus 4, and I get x squared equals, I'm going to write it as negative x over 2 plus 4, just so I can keep in line with the mx plus c. Y equals mx plus c, so I can read off my gradient. So I know that my y-intercept is going to be 4, which is on the graph right there, and I know that my gradient is going to be negative, because it's a negative x over 2, which means the slope's going to be going down. Yeah, and the gradient is going to be negative half, right? Because like you can see here, it's x over 2 is the same as a half x. So the gradient is a negative a half, so that means it goes across 1 down a half. Across 1 down a half. Okay, so from there we can draw on our 4 minus a half x graph, and that gives us that then gives us those 2 solutions. We drop down and we get x is negative 2.3, or x equals 1.8. And if I go really quickly back to Desmos, what did I say it was? Negative 2.3 and 1.8 to 1 decimal place. So there you go. It really, really does work. Now, just whilst I'm in Desmos, I'm just going to draw your attention to one other thing as well. No, I'm not. I'm going to carry on with this. So these ones here, the exercises, you've got using y equals x squared, and then this one also is y equals x squared, right? So from those, you should be able to get to, you should be able to rearrange it so you've got your x and your constant on the other side. So for example, if I took this one, question 1 here, I would be graphing y equals x squared and y equals x plus 3. I'm going to do a really small graph of that, super small, but y equals x plus 3, that's 3, and my solutions are going to be there and there, okay, whatever that may be. Okay, so here is, and then the next question is, though, it says the example, it says, here is the graph of y equals x squared minus 5x, plus 5. Okay, and it's right here. Yeah, it's this green line right here. They've already drawn it. And so you can see that equals 0 is going to be a solution there and there. That's okay, but it then says, by drawing suitable straight lines on the graph, yeah, find the solutions to x squared minus 5x plus 5. Okay, well, 0 is just going to be our 2 solutions there. That's okay. But the next one is different. The next one is we've got 0 equals x squared minus 5x plus 3. Okay, now we don't want it to be plus 3 because this equation, we don't know what that graph looks like, but we do know what that graph looks like. So how do we get, oops, I don't know what I've done there. Right. How do we get from y equals x squared minus 5x plus 3 to x squared minus 5x plus 5? Well, to get from Let's get rid of that bit there. To get from this equation to this equation, we add 2. Yeah. So I'm just going to make a note over here. So we're going to 0 equals x squared minus 5x plus 3. And I just said we're going to add 2. But because this is an equation, we have to add 2 to both sides. So we get 2 equals x squared minus 5x plus 5. Now we should be in familiar territory because we already know what this graph looks like. We've already got it drawn. The book's already got it written for us. And then what we need to do is dial in this graph. Yeah, y equals 2, and see where y equals 2 intersects with y equals x squared minus 5x plus 5. Okay, so where are we going to do that? Well, right about there. Oh, it's a straight line. And what do we get? We get a solution there and there, which is, I don't know, 0.246, 0.65, maybe. And maybe this one here is going to be 4.2, 4.3, 4.3, maybe something like that. Okay. Oh. Well, I'm missing the B, but you can see that from your, you can see that from inside your book. So I was just going to do this last one here as well. Now, because we're almost there, but we've got x squared minus 4x plus 4. Now, I'm going to write that down, x squared minus 4x plus 4, and I want to get to 0 equals x squared minus 5x plus 5. Well, I can see that I'm going to have to take away an x, and I'm going to have to plus 1. Okay, so if I can do that, can't I? But I've got to do the same thing to both sides. I've got a minus x plus 1 on the left-hand side as well. So I'm going to get negative x plus 1 equals x squared minus 5x plus 5. I know what this graph looks like. It's the green line. But I need to draw on this line in order to find my solution. Okay, so hang on. Well, maybe. Here we go. Right, so we've got negative x plus 1. That's my y-intercept. That's my x-intercept. And it's going to go across 1, down 1 to there. Oof. So it's going to be a pretty hairy line. Yeah, there you go. That's not a very good line, is it? Let's try and do a better line, shall we? No ruler function on this. How annoying. Okay. Right. That's a bit better. Okay. So I think maybe there is only one solution at that point where x equals 2. I think that's probably right. Oh, of course. I worried myself then, of course, because if I've got 0 equals x squared minus 4x plus 4, and I factorize that, well, that's a perfect square. It's x minus 2 times x minus 2, okay, equals 0. So x must equal 2 for that bit there, but x equals 2 for that bit there. There's only one solution, which is where those two lines meet. Right. I hope that's a little bit clear. If you have questions, which I'm sure you will, then I will be available every day from 8 a.m. till 4 p.m., Monday to Friday. Send me an email. I will reply to you as quickly as I possibly can. For obvious reasons, I'm predominantly at home, but I have good access to the internet, so I should be able to get back to you ASAP. Uh, I hope this helps, and I will speak to you all soon. Ta ta for now.